Okay, so let's begin here. This is going to be a second video in the series. Okay, and I wanted to mention something about Unicode for you. Okay, so specifically, we're going to be talking about Unicode 16-byte one, so UTF-16. And so here's the thing. Sometimes when you see the main function, the win main function, you might see something as preceded with a W. So it's going to be W win main, and then H instance, H previous instance, and then you're going to see PW string, which is pointer to Y, stands for pointer to a wide string, and then command line, P command line here, and the integer NCMD shows. So what it is basically, as I mentioned before in the previous video a little bit, a W stands for wide character, which is UTF-16 character encoding standard, also known as Unicode. There are other encoding standards that are Unicode also that are like 32 bytes, I think. But in our case, we're going to be using the 16 one, which is the main one here. Okay. So what it does, it makes every character, again, 2 bytes long. So if A is in an ASCII is 1 byte, in a Unicode standard will be 2 bytes in length. So for example, as you can see here, A will be, hex value would be 65, which is, the decimal value is 65. Hex value will be 41, 41 here, which is 1 byte long. And in Unicode, the same thing would be preceded with 0041. So it's easy to convert from ASCII to Unicode and vice versa, because those characters mean the ASCII characters basically have a byte in front of it that is all zeros. Okay. So yeah, and then that's it. So that's what I mentioned for this one here. So let's go a little bit further here. Okay, let's see here. This one go here. So yeah, so letter A, so decimal value is 65, hex value is 41, Unicode 0041. So in a binary form, how it would look for you is as follows. So if you have a 1 byte, okay, which is the ASCII version, so 41 will be 01000001. So that's how it will be represented in memory. Okay, if you have 1 byte. And in a Unicode, you'll be basically the first byte will be the same thing, 01000001, and the 0 byte will be all zeros in front of it. So the 1 byte will have the value, and the other one in front of it will be all zeros. And so how do you convert basically from decimal to hex? So what you do is step one, like if in our case we have the letter A, which is 65, capital letter A. So we divide by 16. So we take 65 divided by 16, we get 4.0625. Then we take the decimal, the remainder basically, the 0625, we take that remainder and multiply by 16. And when we do that, we get 1 here, just 1. And then we take the result, which was 4 here, okay? Take the result and divide by 16, which is, we get 0.25. And then that 0.25, we multiply by 16, which will get 4. And then we take the remainder, I mean the value in front of it, which is in our case is now 0. We take we take the remainder minus the 0.25, which was left there, okay, and we get 0. So we take the remainder and we deduct from the main value, we deduct the remainder to get the next value. So when we go from 65 divided by 16, we get 4.0625. Then we deduct the remainder from this 4.0625, we get 4, which is here. And then, so we take the 4 here, divided by 16, which we get 0.25. And then we take that number minus the remainder, which is 0.25, which is 0 again. So when you get up down to 0, you get your 2 values. So you get 1 here, and you get 4 in front of it. Okay, so that's how you get the 41. And then from hex to binary, what you do, there is a table. So like here, so 0, each digit in a hex is divided into 4 bits. So that makes 1 byte. So 2 digits here make 1 byte, which means there are 4 bits per digit here. Okay, so we get, and this is the table for the hex, so you get all zeros here. 0, 1 is 0, 0, 1, 2 is 0, 0, 1, 0, 3 is 0, 0, 1, 1, 4 is 0, 1, 0, 0, 5 is 0, 1, 0, 1, 6 is 0, 1, 1, 0, 7 is 0, 1, 1, 1, 8 is 1, 0, 0, 0, 9 is 1, 0, 1, 1, A is, so because you can have two digits, so 10 is A, 11 is B, 12 C, 13 is D, 14 is E, and 15 is F, which is 16 because we're going from 0 to 15, which is 16 digits altogether. And then, so yeah, A is 1, 0, 1, 0, B is 1, 0, 1, 1, C is 1, 1, 0, 0, D is 1, 1, 0, 1, E is 1, 1, 1, 0, and F is 1, 1, 1, 1. As you can notice, each time we add 1 to it, a shift, right? So like from here, we add 1, and then when we cannot add 1, we shift 1 over and put 0 there. So that's how it changes. So 4, so we look up 4 here. So this is 0, 1, 0, 0. And 1 here is we take 1 from here, and we get 1, 1, 0, 1. And that's how we get the binary option here. Okay. So let's continue on here a little bit. So now, so in C programming, okay, to get a Unicode character, also called white character, right, you basically put an L in front of the character of the string. So LA, for example, like we have here, will be 2 bytes long. However, if you put like, oh, by the way, very important, if you have single quotation marks, that means it's one character. If you have double quotation marks, then it's a string. Okay, so make sure that's very important difference. Okay, so what happens? The character here does not have a null terminating value, while the string has a null terminating value at the end. Even though you don't see it, you don't add it, the system will add it for you when it's compiled. Okay, so that's, make sure you have a very important distinction, because LA with a single quotation marks will be 2 bytes long. LA with a double quotation marks will be 4 bytes long. And the reason it's going to be 4 bytes long is we're going to have 2 bytes for A and 2 bytes for the null character here, okay, which I show here. So basically, it's going to be represented as L, so LA as a string here. So A as a string is going to be represented as L character A and L character null terminating, right? Which is 4 bytes. So 2 for A and 2 for null terminating, okay? So if you put L quotation marks, double quotation mark A, B, C, you will get length 8, which is 2 bytes for each letter, which is 2 bytes for A, 2 bytes for B, 2 bytes for C. And then you get another 2 bytes for the null terminating character. Okay, and also the Windows API has several macros that, depending if Unicode is declared or not, will either convert character string to ASCII or Unicode. The macros, the main ones are text and _t. They're pretty much equivalent. So what they do, so if you put something like this, if you put text ABC and Unicode is not defined, then ABC will be 4 bytes long. The same defined Unicode. Then, okay, so sorry, this should be 6 bytes long. So if Unicode is not defined, the ABC. Sorry, no, it's going to be 4 bytes, yes, because it'll be 1 byte for A, 1 byte for B, 1 byte for C, and a null terminating string. So it'll be 4 bytes long if Unicode is not defined. And the same string, if Unicode is defined, if you include something like this in front of Windows header file, so if you include define Unicode in front of windows.h, then ABC will be 8 bytes long. So, okay, the same logic will apply to T macro. So text ABC and text _T ABC are the same. So for example, like we have here, so this is a ASCII version, and if we basically do this, it says define Unicode, then we converting basically the message box here to a white version, and I will show you that how it's done there in a few moments. Okay, so that's important here. Now let's go here. So it was here 3. Okay, let's see here 4. Okay, this one. Okay, so what it does is that if Unicode is defined, okay, so this is the definition macro for text and T. So what happens here is as follows. If Unicode is defined, so here it checks if Unicode is defined, then what happens, the text macro will take the string inside and we'll simply put an L in front of T. So this is basically concatenation option. So what it does is it's basically puts L, like it adds L in front of T basically, so links them, concatenates them together. Okay, so like it puts L and T into like it's going to be one string. So as we have here, so like text ABC will be replaced with during the preprocessor option will be replaced with an L in front of it and then ABC. Okay, so basically it's this double pound sign. Okay, it's called token pasting operator. Okay, for the preprocessor, and what it does is just simply adds an L, which is C option for white characters, right, in front of it. So you got L and then ABC in front of it. If Unicode is not defined, then text T will be simply T. So ABC will be simply replaced with an ABC when the preprocessor runs. And those two macros here, okay, the text and T, that as you can see here, they're defined similarly. Okay, just the difference is the underscore T for this one and text T, so they're equivalent. And however, to use the underscore T, you have to include the T character.h in your header files. Okay, so that's, and then let's see here, final one. And this is also Windows API has basically, it's pretty much designed for be used for compatibility as a wide character system for programming. So what it does, it will provide you with lots of wrapper macros for the function. So it's going to have a function for white characters that you can use, or you can have a function for ASCII characters. Okay. So what it is like much like a text macro. So it's here. If you look here, if Unicode is defined, then basic message box will become message box W. So the message box macro will replace that with message box W function. And if Unicode is not defined, then message box will be replaced with a message box ASCII, which stands for ASCII version of the Windows API function for message box. All right, so let's take a look here. So like if you can see here, so this is let's see, let's compile this here for a second. Let's see, it's good. It's not, let's go. Okay, let's see here. That's good, that's good, that's good. All right. Okay, so what we're gonna do here. Okay, so what we're gonna do here, I'm gonna end this video at this point. And the next video, we're gonna go back to programming. This is just was basic general overview, okay, of the wide character system that Windows uses. Because we're going to be using, for compatibility reasons, we're going to be using quite a bit the text T macro. Okay, so that will allow us later on when you write code to basically, we don't have to worry about whether it's an Unicode or ASCII version. If you put text in it, the system will determine that for you. Okay. Okay, so this is going to be a demonstration of the Unicode versus ASCII. So basically we have a basic here message box. I'm going to explain that message box in details in the next video. This is just for basically for the demonstration purposes, so I'm not going to go into details what it does, but basically just displays ABC and in its information area, and it's displays info in its title area, right? And here this is called basically, it just tells you the size of ABC string depending whether Unicode is encoded or not, and this is just going to print off the details. So right now the define Unicode is disabled, so we are working with an ASCII version of this window of the programming. So let's compile, let's look at here and let's run it. As you can now see here, it's ABC displayed, and you can see the string ABC here is 4 bytes long. Okay, so each 1 byte for each ABC plus the null terminating string. Okay. Now let's change this to Unicode. We define Unicode like so. We recompile. Okay. And when we run this one, still we have the same message here. Okay. But as you can notice here, ABC string is now 8 bytes long. So it's 2 bytes for A, 2 bytes for B, 2 bytes for C, and then null terminating. So yeah, so I just want to show you guys that, the difference here. Okay.